Hello, and welcome once again to the Scientific Adventures of Beardman. Today, on the Scientific Adventures of Beardman, I'd like to ponder a few questions. First, where are we? Where are you? And secondly, how fast are you moving? Take a moment. Pause the video and ponder. I encourage you to write it down. Where are you? And how fast are you moving? Now that you've pondered that, let's take a look at your answers. Some of you may have said, I'm sitting down at my desk. I'm in a classroom. I'm in my bedroom. I'm in the kitchen. Then you gave an address. Okay, all right. And maybe you went so far as to mention that you were in California, or in the United States, or on planet Earth, or in the solar system, Milky Way galaxy, a local group galactic cluster. Just how specific were you? Did you use longitude and latitude? Then as you began to think about how fast am I moving, did you just say I'm stationary? Or did you talk about your heart beating? Or the blood pumping through your veins? Or neurons firing as you were thinking? Or did you begin to consider the fact that the Earth is spinning on its axis, and you're going once around its circumference, or close to it if you're kind of near the equator, once a day, every 24 hours? Did you then consider further that the Earth is moving around the Sun? Did you calculate that into your speed? Or that the Sun itself and the whole solar system is whirling at incredible speeds around the Milky Way galaxy? And then, is the Milky Way galaxy moving? What would we compare it to? The point is, where you are, in order to find that, you have to compare it to something. Longitude and latitude, we compare it to the equator, the prime meridian. In terms of speed, normally we define that in terms of where we are on Earth. That if we're in the same place on Earth, then we consider ourselves stationary. If we're moving compared to the Earth. And we seem to ignore the incredible speeds through which the Earth is hurling through space. Is that wrong? Should we always try and consider all those speeds? Well, one of the questions always becomes, what are you comparing it to? And at some point, you're always comparing it to something else. And therefore, speed and position are what we would call relative. They depend on something that you define to be constant. That definition of something as being zero is what we call a frame of reference. So on Earth, for position, the equator and the prime meridian form our frame of reference. Those are defined as zero. For many physics problems we do in this upcoming unit, we will define the Earth as stationary. We're not ignoring the fact that it's moving, but we're going to define everything else as moving compared to the Earth. So when we drive a car, we talk about how fast we're moving compared to a stationary Earth. And that's perfectly fine. We do run into some problems that we'll get to later in the Coriolis effect, because we're moving in a circle as we rotate and revolve. But those will be issues that we'll deal with later. For the most part, we can deal perfectly happily with everything moving compared to the Earth. Now, occasionally we'll have a different kind of problem, like, say, boy is on a train, and the train is going 65 miles per hour. And he is at the front of the train when all of a sudden he realizes he misses his mother. And so he runs at 10 miles per hour back in the train. And that boy is actually, in the Earth's frame of reference, still moving forward at 55 miles per hour, while the train is moving at 65 miles per hour. But what we're often concerned about in a situation like that is how fast is he moving compared to the train. And so for the moment, we would set the problem in a frame of reference of the train, where the train's speed is considered to be 0, and the boy's speed is considered to be negative 10 miles per hour going backwards of the train. When we combine those two speeds, 65 miles per hour, negative 10 miles per hour, we can see that the boy's speed compared to the Earth would be 55 miles per hour. Now, let me end you with one thought. A bar walked into a man. Whoops, wrong frame of reference. Have a good day. We'll see you next time on the Scientific Adventures of Beardman.